Okay. The structure of compacted soil, compacted clay is complicated. At the same compactive effort, the soil structure become increasingly oriented. Okay, increasingly oriented, that is displaced with increasing water content. When compacted dry of optimum, the structure of clay is always flocculated. So normally when we add water with your clay type soil, at that type of soil normally soil behaves like flocculated kind of behavior. Flocculated kind of behavior because the particles of clay are normally very fine, and if we add water, the particles try to float in the water material, and they are started to segregate from each other, and this kind of phenomena only happen in your clay soil. So this is the basic difference, but the important thing in this theory is this figure. In this figure, two compaction curve for a clay, one at lower compacting effort, another is higher compacting effort. Okay, lower compacting effort. This is the clay soil. One is low compacting effort, another is high compacting effort. Now, in this figure, at water content higher than optimum, the soil at points B and D, point B and point D of the two curves is more oriented than at point A. Okay. However, the structure is more oriented at C than at A. This B should be wait. Just the notations are given wrong. Suppose this is A point, this is C point, A, B, C, one curve, E, D, another curve. Okay, this is the low compacting effort curve, and this is the high compacting or compactive effort curve. Okay, now the conclusion is at at C point. Okay, at C point and at this D point. Okay, at C point and D point more oriented than point A. Okay, more oriented than point A at point A. However, the structure is more oriented at C, or C means E. Instead of C, it should be E. At E than at A. So normally nothing is more special. A point, at A point, the value of E point is maximum than A, and the value of D point maximum than C. This is the main thing. Okay, why this is? Because of this compacting effort. Okay, one is low compacting effort, one curve is for low compacting effort, another curve is for high compacting effort. Okay, and totally based on the structure. When the structure of the soil is changed, okay, why the structure has changed? Structure of the soil has changed due to compaction. We have compacted when the we have given a low compact effort. This curve is showing like that under some water content, and when we put the high compaction, okay, comparatively low, normally we put higher compacting energy, then the curve will show like that. But the thing is that the same water content we are getting this the different value due to compacting energy, and this compacting energy normally it is changed the structure of the soil particles. Okay, the structure of the soil particle is changed, and on the basis of practical point of view, I can say the void ratio, as we have the idea as an engineer, soil engineer, we have the idea the void ratio is changed. What is void ratio? Normally void ratio, which is space available in the soil mass. Okay, and this the soil space of the soil mass also a shape of a structure, hollow structure, and this structure is changed due to our putting compacting energy or the compaction. When this compaction is low as per the theory, specified theory, then the water content on the given same water content, it will show like this curve, and when we put the maximum energy or maximum compaction at same water content, this will give like this type of shape or this type of curve. Okay, this is the main function, but my intention or the theory intention of the theory is the structure is changing. We are putting compaction, the structure of the soil is changing due to application of the compaction energy or load. This is the structure. Okay, next is effect on soil structure. Already I have said. Effect on permeability. So one properties of the soil is structure, first properties, then second property on which the soil can the compaction can affect, that is the permeability. Okay, some points are there when we talk about the permeability, or what are the effects of compaction on permeability of soil. Number one, as the dry density increases due to compaction, the voids go on reducing, and hence the permeability goes on decreasing. Same thing, space or voids are decreasing, so soil are less permeable, or water can pass through the soil in a very low quantity or with very low volume. Soil can pass through the water can pass through the soil. For the same density, fine grained samples compacted dry of optimum are more permeable, those compacted wet of optimum. Okay, this is so because these soils have flocculate structure when compacted dry of optimum, and have displaced structure, that is parallel orientation, when compacted wet of optimum. So normally we are perform our test dry sample, because if soil is in wet condition, then normally this fine grained soil, clay soil, will try to float. Okay, try to segregate from each other. But when we take the dry soil for compaction test or for this compaction process, in this compaction process, then the optimum water will reach in the soil mass. Okay, that's why this compaction will be reached in a optimum position when we will take the dry soil. Dry soil will give us the optimum value, always optimum dry density value instead of wet water, because already in wet soil the behavior of the particles will try to segregate from each other, but in dry soil always it will try to take, or it will absorb the water as much as required. Okay, as much as required, and simultaneously when we put the compaction energy or the compaction on the soil, it will get the compacted in a very well way, in a very well manner. Number 3, for a given void ratio, greater the size of individual pores, greater is the permeability. Normally, when the void ratio is maximum, voids are maximum, then the soil is also maximum permeable. Even if you understand, when the sandy soil, when we take the sandy soil, in sand, normally sands are they have no adhesive character or cohesive character, glue type character. Okay, they are normally, what is we can see, normally the pores or voids in sandy soil are maximum. That's why they are more permeable than cohesive soil. Even we have one test in laboratory, that is permeability test. In your permeability test also there are two types of instruments or measurement. One is for fine grained soil, one is for coarse grained soil, because the permeability behavior of coarse grained soil or sandy soil is different, and for cohesive soil or for fine grained soil or clay soil is totally different. That's why in laboratory also we are perform different tests to calculate the permeability value or coefficient of permeability for sand and coefficient of permeability for fine grained soil or clay soil. We are perform different tests. Okay, because of the different behavior of the soil and the structure of the soil. Simply, when voids are maximum, soil is more permeable. When voids are less, permeability is less. Next behavior is sinkage. For the same density, sinkage is one is there. The sinkage for the same density, soil sample compacted dry of optimum sink appreciably less than the sample compacted weight of optimum. This is so because the soil particles having displaced structure have nearly parallel orientation and can pack more efficiently. So sinkage is one of the another properties of soil. You have also the sinkage ratio test, and Atterberg limits. You have the idea in your soil mechanics theory, that is there are three different limit of water content. Okay, one is liquid limit, plastic limit, sinkage limit. That is like liquid limit. Liquid limit is the boundary between liquid state and plastic state. Plastic limit is the boundary between plastic state and the solid state. So same thing, sinkage limit is the solid and dry state. This is the difference. So in that case, minimum water content in sinkage limit or sinkage, where the water content is minimum, where the soil can carry. Sinkage is the minimum water content, a minimum water content which soil can carry, and if we measure with water and without water, that means the water content having the sinkage limit, if we measure the water, if we measure the soil will give the same weight. Even in without water, soil will give the same weight. So this is the minimum water content which can carry the soil, and this water content, even having this water content in soil mass, soil can behave like a sinkage state or the semi-solid state behavior soil can carry. Next is swelling. Okay, swelling is the clay soil sample compacted, dry of optimum water content, has high water deficiency and more random orientation, and hence exert greater swelling pressure and swell to higher water content than a sample of the same density obtained from wet site compaction. Again, I am repeating: a clay soil sample compacted, dry, of optimum water content, has higher water deficiency and more random orientation, and hence exert greater swelling pressure and swell to higher water content than the sample of the same density obtained from wet site compaction. So swelling also same, water content is constant. Okay, minimum water content, these are the we are talking about about such state where soil carry the minimum water content, but still if we measure the soil mass we cannot find out the water. Okay, because in normal process, because this water content occupied by the soil, the pores, very nuclear pores of the soil particles, and the presence of this water, soil can behave different when water is not present. But when we take the weight of the soil with water, this swelling or the sinkage the required water content for swelling and sinkage, if we take weight of the soil, and in the dry condition if we take the weight, there are no difference. Okay, there are no difference. But when the amount which is required for swelling is present in soil, it will behave different. I think you are getting, because this is such a water content we can measure. This is, we have the process, difference process, but in normal process we cannot measure the water content or swelling and shrinkage. But if this water content is present in the water which is required for the swelling, soil will behave totally. Soil will behave differently. Okay, it will very convincing if you perform the sinkage ratio test. From sinkage ratio test, it will be clear, because the sinkage ratio test is totally different from another test. Okay, different from another test. Only from sinkage ratio test you can understand this type of sinkage and swelling kind of behavior of the soil. And for requirement of the water content, or require the water content which is responsible, the amount of water content which is responsible for this swelling or this sinkage, it is totally measurement of process is totally different from our conventional water content measuring. Okay, then after that there is pore pressure. Okay, saturated sample of clay compacted dye of optimum tend to develop substantially lower pore pressure at low stage in undrained shear test than the sample of same soil of the same density and water content compacted weight of optimum. However, at higher stage both the samples exhibit the same pore pressure. Again I am repeating: saturated sample of clay compacted dye of optimum tend to develop substantially lower pore pressure at low stage in undrained shear test. I don't know. Acha, undrained shear test already you had in your theory, but also I think you have performed undrained. No. Drained shear test you have performed. Undrained shear test you have not perform. Uh, okay, we can skip this because these things are related to your uh, mm, lab test. Some lab tests you should perform because in soil mechanics one you had not any lab. Okay, you are, all of you are performing lab in this present semester, so very difficult to understand these things. Now I am trying to give you something. Next is compressibility. Okay, compressibility or pressure, same thing. Compressibility. Standard sample of clay compacted wet side of optimum is more compressible than another sample of the same soil. Saturated sample of clay compacted wet side of optimum is more compressible than another sample of same soil. Having the same void ratio but compacted dry of the optimum when the applied pressure is low pressure range. This is so because the sample compacted dry of optimum has flocculated structure and requires extra pressure to cause parallel orientation of particles. Same thing. Pressure is also same thing. Effects of sinkage, effects of compressibility. Now this is the effect of strain stress. Effect of strain stress or stress strain relationship. Okay. Effect of stress strain relationship. For a given soil, a sample compacted dry side optimum has a steeper stress strain curve and hence a higher modulus of elasticity than the one which compacted wet of optimum. In figure, at the same density, soil compacted wet of optimum have brittle failure, while soil compacted wet of optimum and having dispersed structure continue to increase in strength even at higher strength. So this is the stress strain behavior of the soil. This is the wet compacted, this is the dry compacted. And it is said the in this figure at the same density as the soil compacted wet of optimum have brittle failure. Compacted weight of optimum have brittle failure, while soil compacted weight of optimum having dispersed structure. Okay. And this dry side of optimum has a steeper stress strain curve and hence has a higher modulus of elasticity. When we perform dry compacted, there is higher modulus of elasticity. The thing is important is this modulus of elasticity. Okay, in practical applications, our civil engineering field applications, or when the soil mechanics knowledge of soil mechanics is required for any construction site, these things are totally today what are the things I am discussing totally on based on the theory, maximum theory, or the related to physics apart from your application part. Okay, application means when we are adding some water, we are getting some density, we are this is simple things which are related to direct application. These things are research kind of thing. Okay, basic mechanics, basic theory are involved, like soil like other materials. If we consider like soil, we can perform the stress strain behavior. If we take wet compacted soil, we can see like this type of graph or this type of curve. When we take the dry compacted soil, we can see this type of curve, which is obviously shows the modulus of elasticity type of curve. This is shows like a brittle type of curve. So these things are not is directly involved to our practical application, this is the thing is the research kind of thing. This is the basic things, mechanics kind of things, physics kinds of things, but this also involved in your syllabus, may come as a your theory question, may asked in your semester exam. But the important things already I have given to you. I think you have you got the things which is directly related to the your fundamental things which you have studied in earlier classes. These things are involved in your syllabus, but also these things are important for MTech. I have studied these things are MTech. Okay, in BTech already whatever I have studied, whatever I have given to you in the earlier classes, those things are very important for your BTech. Okay, these things are included or given in your syllabus, but this is a research kind of thing. This is a very basic kind of things, mechanics kind of things. There are no such direct relation with your practical applications or engineering applications or field applications. Okay, so another thing is there, that is shear strength. Okay, after this shear strength relation, shear strength is there. The shear strength of compacted clays depends upon dry density, molding water content, soil structure, method of compaction, strain used to define strength, drainage condition and type of soil. In general, at low strains, strength of compressive soil compacted dry of optimum is higher than those compacted wet of optimum. Also, one figure is there, that is the one is for wet soil, and this is the graph, normal stresses versus shear stress. So normal stress and shear stress plot are given, and two curves is there. Curves are there. One is for wet side, another for dry side, and this figure shows the failure envelope of two samples of the same soil. One compacted dry of optimum, another compacted wet of the optimum, but both compacted at the same density. However, of higher strains, the flocculated structure of the same compacted on the dry side is broken, giving rise to ultimate strain for both the samples. The manner of compaction also influences the strength of soil sample, compacted weight of optimum. It is interesting to note that the clay cores in earth dams are usually compacted weight of optimum to tolerate large settlements without cracking. In shear strength chapters, normally this failure envelope, where we have studied the more circle, more circle related studies, we have seen the, or we have some idea about failure envelope. Okay, failure envelope. So one is for wet side, one is for dry side. They wants to mean that if dam construction, in dam construction normally earthen dam, they are I think you have the hydrology chapter also. I don't know dam you have, do you have the idea of dam or not? There are lots of dam: earthen dam, concrete dam, steel dam, wooden dam. Okay, barrage. This kind of structures are normally we are studied in our hydrology, irrigation subjects. Even soil mechanics, even foundation engineering, we have the earthen dam. Okay, because soil properties, behavior of the soil properties is important to counter the load, counter the action of water, counter the external force. Different kind of the movements are involved in earthen dam or in dam also. So this wet side, okay, this is wet side when my soil is directly contact with water, or the environment of the surrounding soil is water, or water is present surrounding the soil, but I have to maintain the strength of my soil, then this weight density is important to me. Okay, weight density means soil will not fail. Okay, soil will not collapse due to external load, but as we know, due to presence of water, soil can change its density, because when soil contact with the water or moisture, automatically soil the density of the soil will decrease. But if we maintain the proper weight, proper pressure, proper confining kind of situation, then normally soil will maintain its density with any kind of circumstances, any type of circumstances. So this weight density is important at that time, and the dry density already I have the idea, we have the idea that how can we maintain the dry density, or through dry density we can find out the maximum density of the soil. Okay, but weight density is important where the my soil is totally open to the water kind of environment, where the water is present, like dam, earthen dam, waterlogged area, any the road construction in waterlogged area, or suppose in rainy area in Cherrapunji, always raining is going on. Okay, maximum rain is going on in Cherrapunji, in northern part, even in northeastern part of the country, where you have to construct your road, you have to construct such kind of structure, earthen structure. Then what you will do at that time? This weight density is important to maintain, but the proper function of the weight density, for the idea of the proper function of the weight density only possible when you will perform all the lab tests, like your the shear strength tests. During shear strength test you will get some idea of weight density, even the compressibility, relation between compressibility and the shear strength, relation between the drain condition, undrained condition, and the compression and the drain condition combination. This type of combination you will get the idea from your all the shear strength test. So for the time being, I will not continue these effects or parameters which are affected by the compaction, but these things are involved. These things are all are present in your syllabus. Okay, structure, more random, more oriented. Permeability, more permeable, less permeable. Compressibility, more compressible in higher pressure range, more compressible in low pressure range. Swelling, swell more, shrink more. Strength, higher, lesser. These two types the density are used normally, but this is a very special kind of density, weight density. Normally it is not used in our structure, or to maintain this density is very difficult. Okay, during construction. Okay, I will stop here. Just wait, I am taking the attendance. Thank you. The compaction chapter is over. After that, let's see what is the next. Okay, thank you. You can leave.